Okay, we want to talk about graphing exponential functions in this particular section. What does it mean when we talk about something? So when we come back in the spring, we'll talk about modeling for it with exponential functions. But what does it mean to say something had exponential growth? What does that conjure up for you? Yeah, it's like it's explosive. It's growing. Okay, so if I were to tell you one of those functions has exponential growth and one does not, which one do you think has exponential growth? Yeah, the one that's going up. Okay, so exponential growth usually means, okay, it's going to start growing and it's going to continue to grow. That's what exponential growth would mean. This is an actual chart for Snapchat users. So I showed, this is an example of Snapchat was looking at, this was taken in, when was this? I think it was 2015. They had two different models for their growth. Okay, both of these models project them growing. You know, if I'm Snapchat, which of these models do I want to believe? I want to believe the higher one. I want to believe that that's where it's growing. In reality, you can't sustain that. You know, so yeah, Snapchat 2 or 3 years ago, exponential growth in the number of users. I would say it's probably not exponential now. You know, you're not, so exponential means I'm doubling, you know, every so often, you know, as opposed, so it's probably slowed down since then. Let's look at a couple of scenarios. So when we look at models like this, what if these charts represented revenue? Okay, so that was just user growth. If both of these charts represented revenue, which one am I wanting to be the one? Yeah, the one that's going up higher. That's what I want. If these charts represented cost, which of those two models would I prefer? The one that was growing less rapidly, okay, the lower one. If these graphs were showing shareholder value of the company, which one would I prefer? The one that's going up, the one on top, okay? So when we get back after Christmas, we will be dealing with exponential models, graphs of these things, and being able to make interpretations from word problems. But now, what we need to do to get ready for that is we need to be able to graph exponential functions, okay? So just like we graph parent functions, we can graph functions that are exponential. This is an exponential function. I've got 2 raised to an exponent, okay? So I need to be able to graph this. I'm just going to plot points, and you'll see what the graph is. I usually like to start with 0. What is 2 to the 0? 1. Every number to the 0 power is 1, except for one number. 0 to the 0 is undefined, okay? Any number to the 0 power is 1, okay? What is 2 to the 1? 2. 2 squared. 4. 2 cubed. 8, okay? Those are the easy ones. What is 2 to the negative 1, okay? How do I rewrite that with a positive exponent? That's what? 1 over 2 to the 1. What's 1 over 2 to the 1? 1/2. Okay. 2 to the negative 2 is what? 1 over 2 squared, which is 1/4. And 2 to the negative 3 is 1/8. So 0, 1, 1, 2, 2, 4, and 3, 8. Okay. And then let's see, it's negative 1, 1/2, negative 2, 1/4, 1/8. Okay. Can you see what this graph is doing? This would be like a yes, this graph is going up right here. And then it looks like it's headed down to the y-axis there, okay? So it has exponential growth. Yes. Okay, so 2 to the negative 3. I'm seeing a negative exponent in what part of the fraction? Numerator or denominator? Numerator. Basic top of the fraction. It's negative in the top of the fraction. It becomes positive when I move it where? To the bottom of the fraction. So that's just 1/8. Okay. 2 to the negative 2. Yeah. That's a negative in the top of a fraction. It becomes positive in the bottom of the fraction. That's 1/4. Okay. So that's how you get those particular numbers. Okay. So this is the graph of 2 to the x. This one has a horizontal asymptote. Can you see where the asymptote is? It's this line right here. What's the equation of that line? That's a horizontal line. What is the equation of that line? Not x, y equals 0. All the y values are equal to 0 on that line. It has all different x, but every y value is equal to 0. So this is I have a horizontal asymptote at the line y equals 0. Okay. What is the domain of this function? Where do my x values start? Negative infinity to where? Positive infinity. Okay. What is the range of this function? How do I find the range? Start down here. Are there any y values down here? I don't see y values until I get to 0, but I actually see a value at 0. No, so it's 0 to infinity. Okay. Remember the asymptotes, you always have a parentheses around that interval because you don't actually have that value. Question? An asymptote is like a wall or a line that this graph does not cross. Okay. So this graph is approaching 0, but it is not ever going to get there, and it's not going to cross. Okay. So it's just something that it's going to hover near that particular line. Okay, so that's pretty straightforward, graphing 2 to the x. Okay. So what we were able to do, we were able to graph everything, and then I'll rewrite this. This is what I asked up there a moment ago. Negative infinity to infinity, and 1 to infinity was the range. 0, yeah, sorry, you're right. 0 to infinity was the range, and the horizontal asymptote was at y equals 0. So that's pretty simple, graphing f of x equal 2 to the x. Now, they're going to change a little bit. What do you think this one is going to look like? Yeah, based on what you've known in the past, if I graphed, a polynomial and then I stuck a negative in front, what happened to it? It flipped over the x-axis. Okay, so this should look like, this basically should just be reflected about the x-axis. Okay, so it should be that same graph reflected over the x-axis. Okay, so I got a couple ways of doing this. I can graph the original 2 to the x and then reflect it over the x-axis. Or I could just pick, instead of all those points that I picked before, you can pick 3 points and pretty much know what this graph is doing. What I will pick is I will pick 0, and I pick a number on either side of that. Okay, so what is negative of 2 to the 0? Okay, what's 2 to the 0? 1. What happens when you stick a negative in front of that? Yeah, negative 1. Okay, keep in mind this is different. These are 2 different things. Okay, this one is equal to 1. This one's equal to negative 1. Those are 2 different things there, because the exponent, it applies to what is immediately to the left. So in this case, immediate to the left is the number 2. Immediate to the left is the number negative 2. These are 2 different things. Okay, so what is negative of 2 to the 1 power? Well, this says that what is being raised to the 0 power? Negative 2. So negative 2 raised to the 0 power is 1. This says what's being raised to the 0 power? It's 2 being raised to the 0, and there's a negative in front of it. Okay, so the exponent only applies to one thing immediately to its left. Okay, so what is negative 2 to the 1? What's 2 to the 1? 2. What happens when you stick a negative in front of a 2? You get negative 2. Okay, negative 1. What is negative 2 to the negative 1? What's 2 to the negative 1? What number is that? 1/2. What happens when you stick a negative in front of 1/2? Negative 1/2. So I've got these 3 points, 0, negative 1, 1, negative 2, and negative 1, negative 1/2. Okay. Do you think you know what this one is doing now? Yeah, it's going to go down. Okay, so it looks like it's doing this. And then it's doing something like this. Okay. So it's only going up or down unbounded in one direction. This one is going down. Okay. Now originally, if I looked at remember what was 2 to the x? 2 to the x was the graph that did this. So this is what 2 to the x looked like. So the other way you could have done this is you could have graphed 2 to the x, and then you could say, let me reflect it about the x-axis. Okay. I found with these exponentials, it's just quite as easy to pick the 3 values, plug them in, and then I see exactly what is going on here. Okay. So if I look at this, do I ask questions underneath this? What is the domain of this function? Yeah, I wanted you to graph the reflected version. So you've got choices of how you want to do this. You can just pick 3 points, plot it, and you're done. Or if you wanted to graph the original 2 to x and then do the reflection, I think some people find that a little bit more work because you've got to graph something and then do the reflection. Whereas before, in parent function, remember, I would give you a graph and make you do a reflection. So this is a little bit different. You've got a choice of ways of doing it. I find that most people prefer to just let me pick 3 points and I'm done. Okay. What's the domain of this function? Yeah. Negative infinity, infinity. That is the answer for all of these guys. What is the range of this function? Yeah, negative infinity up to 0. What is the horizontal asymptote on this graph? Yeah, the line y equal 0. It will not. Maybe the next one is not y equals 0. So we will see how that works. Yeah, the next one will have a different one. Now, remember what we graphed y equal 2 to the x. What do you think 2 to the x plus 1, what do you think that's going to do? Move it where? Not right, not left. Up. It's going to move it. Anytime there's a number on the end, that's just going to move it up. So this looks like it's been moved up 1. Okay. Now I've got choices. I can graph 2 to the x, and then I can move it up 1, or I can just pick these 3 values here. Okay. So what is 2 to the 0 plus 1? What's 2 to the 0? 1. What is 1 plus 1? That's 2. Okay. What is 2 to the 1 plus 1? This is 2 plus 1. What number is that? 3. Okay. And then 2 to the negative 1 plus 1. What is 2 to the negative 1? Not negative 1/2. 1/2. What is 1/2 plus 1? 1.5. Okay. So it looks like I've got the points 0, 2, 1, 3, and negative 1, 1.5. Okay. Okay, just from those 3 points, you can see what's happening. This thing is going to be going up to the right here. And it looks like it's going to be doing this. Now, where is the asymptote here? The asymptote is where? Yeah, y equal 1. Is there a clue that the asymptote is y equal 1? Do you see anything there? It's an indicator. The 1, okay? The previous problem was something like this. What was the asymptote in that problem? Y equals 0, okay? Whatever this number is off by itself, you're going to have a horizontal asymptote at that point. If this had been 2 to the x minus 5, your horizontal asymptote is y equal negative 5. So whatever that number is off by itself is your horizontal asymptote. So what is the domain of this function? Yeah. Don't miss this one. They all have the same answer. What is the range of this function? 1 to infinity. And what is the horizontal asymptote? Y equal 1. Okay. Now, before I even graph this one, y equal 2 to the x minus 1. What is the horizontal asymptote? Yeah, y equal negative 1. Okay. So I know, yeah, it's y. I know y equal negative 1 is my horizontal asymptote. I can see that just by looking at the function, that negative 1 off by itself. So at negative 1, there's my horizontal asymptote. Okay. Let's just put in these values. What is 2 to the 0 minus 1? What's 2 to the 0? 1. What's 1 minus 1? 0. Okay. What is 2 to the 1 minus 1? This is 2 minus 1. What's 2 minus 1? 1. Okay. And then 2 to the negative 1 minus 1. What's 2 to the negative 1? No. 2 to the negative 1 is 1/2. It's 1 over 2 to the negative 1 is 1 over 2 to the 1. It's 1/2. So this is 1/2 minus 1. What's 1/2 minus 1? Negative 1/2. Okay. So those are my 3 points. 0, 0. That's right here. 1, 1 is right here. Negative 1, negative 1/2. Okay, just by those 3 points, can you see what the graph is doing? Yeah, it is doing something like this. Yep, 3 points are all you need. Once you see the 3 points, you see which way it's headed off. You know, either it's going rapidly up or rapidly down, and then it's going to be hugging a line or an asymptote. You can see which side of that is happening. Okay, domain of this function, like all of them, is what? Yeah, negative infinity, infinity. What's the range of that function? Negative 1 to infinity. Now, this one calls back something we did earlier. So instead of 2 to the x and then a minus 1 off by itself, this is moving the graph. Which way is this moving the graph? Not down. It's left or right. I'm hearing everything, okay? Remember, what was it we had to remember about this kind of thing? What was it we tried to remember? It was backwards. In a perfect world, I would love to think that moves you 1 to the left, but it doesn't. It moves you 1 to the right. So this is 2 to the x, and then 1 to the right, okay? So you could graph 2 to the x and move everything 1 to the right, or like I said, you can just pick these points. Now here's the key here. I'm picking 3 points, okay? What was the middle point every time in the ones I've graphed so far? What was I picking? I was picking 0, and I was picking one number on either side of it, okay? What you need to do here is you need to figure out, where does x minus 1 equal 0? When does x minus 1 equal 0? X is equal to what? Positive 1, okay? And then I pick a number on either side of it, okay? So what you want to do is you look at this exponent. So you want to say, where is x minus 1 equals 0? That's when x equal to 1. So my points are going to be 1, 2, and 0. Those are my 3 points, okay? So I want to pick where that expression is 0, one number on either side of it, and those 3 points will give me my graph. So if I plug in a 1 here, I get 2 to the 1 minus 1. What's 1 minus 1? Here, what's 2 to the 0? 1. Okay. And then right here, this is going to be 2 to the 2 minus 1. What's 2 minus 1? 1. What's 2 to the 1? 2. Okay. And then this is going to be 2 to the 0 minus 1. What's 0 minus 1? Negative 1. What's 2 to the negative 1? 1/2. Okay? So those are my points. 0, 1/2. 1, 1. 2, 2. Okay? Do you see what this graph is doing? It's headed up to the right, okay? And it's doing this, okay? So what is the asymptote here? Yeah, there's a 0 off to this by itself there. So the asymptote is y equals 0. Domain, negative infinity to infinity. And the range is from where? 0 to infinity. Okay. So the key here is I didn't have 2 to the x. I had 2 to the x minus 1. So my 3 points are, where's that exponent 0? And then pick a number on either side of that. And those numbers will give you the values you want. So in this case, I'm graphing 2 to the x plus 1. If I think of 2 to the x, this is that same graph, but it's shifted where? To the left by 1. So this is 2 to the x, and then you just basically go left 1, okay? So I could graph 2 to the x and shift everything to the left, or I could just pick 3 points, okay? The points that I want to pick are, where does x plus 1 equal 0? What does x have to be for that to be 0? Negative 1. So I pick negative 1, and I pick the number on either side of negative 1. Those numbers are negative 2 and 0. Okay. On your quiz, you're not going to be given that. You have to do this, okay? So where is this thing equal to 0? When x is negative 1, pick a number on either side. That guarantees you're going to get something that works out like this. 2 to the negative 1 plus 1. What's negative 1 plus 1? 0. 2 to the 0 is 1, okay? And this is then going to be 2 to the 0 plus 1. That's 2 to the 1, which is 2. And then at negative 2, I get 2 to the negative 2 plus 1. What's negative 2 plus 1? Negative 1. What's 2 to the negative 1? 1/2, okay? So I'm getting these same points. So negative 2, 1/2, negative 1, 1, 0, 2, okay? And you can see what this graph is doing. What is the horizontal asymptote here? Y equals 0, okay? So y equals 0 is our horizontal asymptote. The range of this function, 0 to infinity. Domain is negative infinity to infinity. Okay? Now, let me just go back on this particular one. Just if you don't like picking these points, like I said, the other way to do this, and you've got a choice of how you want to do this, is I could graph 2 to the x and then just move it to the left by 1. Okay, 2 to the x. How do I graph 2 to the x? Okay, so 2 to the 0 is 1, 2 to the 1 is 2, 2 to the negative 1 is 1/2. Okay. So that graph is, let's pick gray, negative 1. So negative 1, 1/2, 0, 1, 1, 2. So that's what this one looks like. Okay. If I remove every point to the left 1, this point moves to here, this point moves to here, and this point moves to here. Okay. So that means this graph is just going to be this. So this one is, that's 2 to the x, and this is 2 to the x plus 1, okay? Which way do you prefer? Do you like doing this, graphing the original and then the translated? Or do you like picking points? Okay, and like I said, there's no right or wrong here. I feel like it's a repeatable process just to pick 3 points and you're done with it, okay? So you should be able to graph exponential by I said a few points. You should be able to pick 3 points. And I'm strategically picking 3 points every time that I know will give me the shape of that graph. And then when you see a function that looks like this, whatever this number is off by itself, that is your horizontal asymptote. So if I gave you a graph that looked like this, you know, -4 to the 2x plus 7 minus 5. What's the horizontal asymptote there? -5. Y equal -5 is the horizontal. This gets a little bit more complicated, but the horizontal asymptote is going to be y equal -5, that number that's off to itself. Yep. Which one? This one? 2 to the 0 plus 1. 2 to the 0 is 1. This is 1 plus 1, which is 2. Yes. Well, no, what? What you always do, you look and see, I'm graphing 2 to the x plus 1. I want to figure out, where does x plus 1 equal 0? X plus 1 is equal to 0 when what happens? When x is -1. That's the one that I graph here, okay? And then I pick a number on either side of it. So you always, whatever this exponent is, what makes it 0? That's your middle number. Pick the number on either side of it, okay? So you should be able to take a look. I don't want to do, let me just do one real quick. We'll just do this real quick. 4 to the x. Everything we did was 2 to the x. Nothing changes here. What's 4 to the 0? Well, nothing changes. Something changes. 4 to the 0 is 1. What's 4 to the 1? 4. What's 4 to the -1? That's 1/4. Okay, so this one looks like 1, 4, 0, 1, and 1/4. This one is 4 to the x growing quicker than 2 to the x. Yeah, everything's going up by 4. It's quadrupling every time. So it's a bigger exponential growth. So that's what 4 to the x looks like. What is the horizontal asymptote? Yeah, y equals 0. Off by itself. So y equals 0. The domain, you should get bored writing the domain on all of these. And then the range is just 0 to infinity on this guy. Okay? Then if I look at this one. This one's a little bit different, 4 to the -x, okay? We'll talk a little bit about this tomorrow, but this reflects it about the y-axis. But my key is, take that -x. If -x is equal to 0, what is x equal to? What? No. 0. If -x is 0, x has to be 0. The negative of, what number when you take the negative of it do you get a 0? 0, okay. So x is 0, so I pick the number on either side. So this is, what is 4 to the -0 power? That's 1, okay. What is 4 to the -1 power? 1/4. Pardon me? Okay. And then this is 4 to the -1. What's -1? Yeah, so this is 4 to the 1. What is that? 4. Okay. So this graph is -1, 4, 0, 1, 1, 1/4. Okay. Now this is exponential, but what's different about this guy? Yeah, instead of going up to the right, it's just doing what? It's going up to the left. So this graph looks like this. Okay. What is the horizontal asymptote? Y equals 0. Okay. So this one, y equals 0. The domain, if you miss the domain on this, you're just not paying attention, because they're all the same. The range of this guy is 0 to infinity. It starts at the asymptote and it goes up. Now look at this one. Before I do anything, what is the horizontal asymptote? Y equal 1. Okay, so I don't want to miss that. So y equal 1. And what that can do, that can help me with my graph. I know there's a horizontal asymptote at y equal 1. Okay, so let's plug in values. What is 4 to the 0 plus 1? What's 4 to the 0? 1. What's 1 plus 1? 2. Okay. What's 4 to the 1 plus 1? That's 5. 4 to the negative 1 plus 1. What's 4 to the negative 1? 1/4. 1/4 plus 1 is 1 1/4. Okay. So negative 1, 1 1/4, 0, 2, 1, 5. And then what you see this graph doing is something like this. What's the domain? Negative infinity to infinity. What is the range? 1 to infinity. Okay. And let's take a look. I think we got this one. Okay, before I do this one, what is the horizontal asymptote? Yeah, there's a 0 off to itself here. So y equals 0 is the horizontal. And I can go ahead and graph that. Now, the exponent is x plus 1. To find these numbers, okay, if x plus 1 is equal to 0, what does x have to equal? No, no, no. If x plus 1 is 0, x has to be equal to negative 1. So that's how I get this negative 1 here. And then I pick the number on either side of it, okay? Negative 2 and 0. And that's going to give me these 3 points, okay? So let's look at what is 4 to the negative 1 plus 1? That's 4 to the 0. What's 4 to the 0? 1, okay? And then come here. What is 4 to the 0 plus 1? That's 4 to the 1, which is 4 to the 1, which is 4, okay? And then this one, what is 4 to the negative 2 plus 1? What's negative 2 plus 1? Negative 1. What's 4 to the negative 1? 1/4. So I've got the points negative 2, 1/4, negative 1, 1, 0, 4. Okay? So this graph is doing this. It's 4 to the x shifted where? 4 to the x shifted to the left by 1. Okay? So the domain is negative infinity to infinity. Yeah. So domain is negative infinity to infinity. What is the range? 0 to infinity. And is there one more, or are we done? Oh, then we're into the homework. Okay, so notice, guys, in the homework, I'm not giving you these points, okay? So what points am I going to pick here? 0, and I pick a number on either side, negative 1 and 1, okay? And then when I get to the, let me scroll down to this guy. If I'm graphing 3 to the x plus 2, okay? If x plus 2 is 0, what is x? Negative 2. I'm going to write that number right there. What number's on either side of that? Negative 3, negative 1. Okay? No, I'm not going to give you the points. This is the way that you pick this is the way you pick the 3 points that are going to give you that same behavior every time. It's going to give you something at where it's at 0, where it's going up, and then where it's hugging the asymptote. So if I plug in these numbers, I'm going to get things that look familiar to me. So like, what is 3 to the negative 2 plus 3? What's negative 2 plus 3? Oh, wait, sorry, plus 2. What's negative 2 plus 2? 0. 3 to the 0 is, yeah, so you're going to get these same y values every time. Okay, if I put in a negative 1, what's 3 to the negative 1 plus 2? Negative 1 plus 2 is what? 1. 3 to the 1 is 3. Okay, and then 3 to the negative 3 plus 2. What's negative 3 plus 2? Negative 1. What's 3 to the negative 1? 1/3. Okay, so you're getting these same y values. It's just that this thing has been shifted around. So what you want to do is, whatever this exponent is, find what makes it 0. Plot that point and then 1 point on either side, and that will give you the behavior that you want. So I think if we look at all of those, that should be fairly straightforward. Okay.